Assalamualaikum warahmatullahi wabarakatuh and hello everyone. Today our group will be presenting about case study for subject DJA50082 Vehicle Dynamics from Department of Mechanical Engineering at Polytechnic Kuching Sarawak. So the vehicle we choose for this assessment is Evo 10. Alright, for the introduction, the Mitsubishi Lancer Evolution 10 GSR GST F0300 is a higher performance all-wheel drive sedan powered by a 2.0-liter turbo engine producing 300 horsepower and 407 Newton meter of torque. So this case study focuses on analyzing the forces acting on the vehicle, including aerodynamics, suspension stiffness, and load distribution. Alright, the objective of this case study is to analyze the dynamic performance and handling characteristics of the Mitsubishi Lancer Evolution 10 using a real vehicle data. So this includes evaluating axle load distribution during uphill acceleration, calculating tractive force across gear ratio, and assessing traction limit. So the study also aimed to classify aerodynamic modification to improve fuel efficiency, determine tire stiffness and suspension behavior, calculate ride rates and natural frequency, and apply Ackermann steering geometry to assess cornering angle. Additionally, the study reviews tire specifications to identify their impact on grip, comfort, and fuel economy. Overall, this analysis supports a deeper understanding of how engineering design affects vehicle dynamics, stability, and performance. Okay, for question number one, on the right side, we have the question and the answer for the calculation. And the analysis we get is when accelerating uphill, weight shift to rearward due to inertia and incline. The vertical load transfer is calculated using the formula given, which is AW equal to M times A times H, where M is a mass, A is acceleration, H is the center of gravity height, and L is wheelbase. Alright, so this increases rear axle load, improving traction, but reducing front grip. So the Evon 10 SAWC system, active center differential plus active yaw control, dynamically adjusts torque split to maintain stability. And also the suspension geometry and low center of gravity, engine block lowered by 10 millimeter, help reduce excessive pitch and maintain balance. So the conclusion we get is the Evo 10 is engineered to handle aggressive load shift during hill climb, maintaining traction and steering precision through advanced all-wheel drive and suspension system.
Alright, now for question 2, there are two parts. Question 2A and 2B. As you can see from the calculation shown, question 2A is we have to determine the vehicle tractive force from the first until the fourth gear. While question 2B, we have to determine the traction limited acceleration if the coefficient of friction is 0.62. Alright, now for the analysis, the Evo X maximum traction force is, as you can see from the formula, it is F max equal to M times V. So you have 0.8 times 1590 and times 9.81, which is gravity, equal to 1200 and 470 Newton. Now, since the E total is less than the E max, the car can accelerate without wheel slip. The AYC and the ASC system ensure torque is distributed efficiently, preventing understeer or oversteer. So in conclusion, the Evo X drivetrain and electronic control system are more capable of delivering the required tractive effort under uphill acceleration.
Okay, for question number 3, classify the modification needed to reduce aerodynamic and increases fuel economy. Alright, for the reduced aerodynamic drag, the modifier we need is front bumper spoiler or air dams. Number 1 is front design improvement. So we get a smooth or reduce the large front grille and air vents to lessen. Number 2 is add flat underbody panel, covers the bottom part of the car to reduce turbulent airflow underneath. Number 3 is adjust rear spoiler and vortex generator. We use smaller or streamlined designs to lower the drag while keeping stability. Alright, for increases fuel economy, the modifier we need to use is optimization. So number 1 is lightweight material. Use aluminum or carbon fiber for body parts to reduce total vehicle weight. Number 2 is engine tuning for efficiency. Adjust ECU settings for better fuel control during normal driving. And last is low rolling resistant tire. Replace a high grip sport tire with efficient road tire to reduce friction.
Moving on to question 4, the ride rates, which is up to 28,000 Newton per meter, and natural frequencies at 0.94 Hz for the rear and zero point 0.3 Hz for the front, show balanced suspension. This provides good comfort and stable handling for daily and spirited driving. The front and rear stiffness are well matched, ensuring predictable control. For track use, slightly stiffer springs can improve response but reduce comfort. Overall, the Evo X suspension offers a solid balance between performance and ride comfort. In conclusion, the results show that the front and rear ride rates are giving natural frequencies of around 0.94 Hz for the rear and zero point 0.3 Hz for the front. These values fall within the normal range for passenger vehicles, including indicating a suspension system that provides good comfort and stability.
Question 5. The achievement geometry. Wheel angle analysis. Achievement geometry ensures that during a turn, the inside will turn more sharply than the outside wheel, with a track width of 1,545 mm and wheelbase of 2,650 mm. The Evo X maintenance precise steering angle. This improving cornering accuracy and reduced tire wear, combined with active yaw control. The system enhances agility and drive confidence. In conclusion, the steering geometry support angle handling and minimize tire wear during the tight maneuver. Ini adalah contoh jalan penggerakannya. Inside, formula yang digunakan adalah data Evo adalah wheelbase 2650 mm tukar kepada 2.65 mm. T pula adalah 154 mm tukar kepada 1.545 m. R pula adalah 5.9 meter. Formula digunakan dalam inside adalah tan negatif kuasa 1 dalam kurungan L bahagi R. Tan negatif 1 2,65 bahagi dengan 5,9. Jawapan akhirnya adalah 24,19 darjah. Formula untuk outside pula adalah tan negatif 1 L bahagi R tambah T. Tan negatif 1 dalam kurungan 2,65 bahagi 5,9 tambah 1,54 tutup kurungan. Jawapan akhirnya adalah 19,59 darjah.
For question 6, the advantages of tire changes based on a review of a tire specification is that it is improved in terms of traction and handling. We have decided that we would be upgrading to tires with better tread design or softer compounds can enhance grip, which also would help with cornering stability and braking performance. Next would be enhanced ride comfort. The tires with optimized sidewall flexibility or higher quality materials reduce vibration and road noise. Next would be better fuel efficiency. The low rolling resistant tires reduce energy loss, which would improve fuel economy. Next is increased load capacity. The changing to tires with a higher load index can support heavier vehicle loads. Next, moving on, I will be talking about the disadvantages of tire changes based on a review of a tire specification. First, we have that it reduced fuel economy. The wider or heavier tires increase rolling resistance and vehicle weight, leading to higher fuel consumption. Next, we have the speedometer accuracy. Changing tire diameter affects the overall wheel circumference, causing incorrect speedometer and odometer readings. Next, we have increased wear and maintenance costs. Performance tires often wear faster and are more expensive to replace. Lastly, potential ride harshness. With a low profile tires, it would reduce cushioning, which would make the comfortability less, which would also make the ride become more harsh.
In conclusion, the Mitsubishi Lancer Evolution X is a well-engineered sports sedan that combines power, balance, and control through its advanced vehicle dynamic. Its power turbocharged engine, effective weight distribution, and aerodynamic design contribute to excellent acceleration, stability, and fuel efficiency. The suspension and steering system provide precise handling and comfort, while the tires setup ensures strong grip and performance. Overall, the Evo X reflects how careful engineering and force analysis can create a vehicle that performs exceptionally well in both everyday driving and high-speed conditions.
Alright, so lastly for the reference, we have three items that we use to gain all of our information from. The first one is the Mitsubishi Lancer Evolution X owner manual. That is where we gain all of the info about the Evo X, such as the wheelbase, the weight, the gear ratio, so on and so forth. The second one is we use the book Fundamental of Vehicle Dynamics, written by Thomas D. Gillespie. That's where we learn how to use all the formulas for the calculation, all the units, all the symbols, and yeah. And the last one is Mitsubishi Lancer Evolution 2011 UK model. So that is all the references we used to for this case study, and that is all from our team. Thank you so much for your time. Bye.